In section 15E, we're looking at the volume of a cylinder, and there are some similarities with what we did to determine the volume of prisms. And the reason for that is that when we take a cross-section of a cylinder, we notice that each cross-section is a circle that has the same area as the base of the cylinder. Cylinders are incredibly common shapes, and one example is columns in buildings. And from an engineering point of view, circular columns are actually stronger than columns that may, for example, have a square base or an octagonal base. We know that cylindrical columns are the strongest of all. Other very common examples are cans for food, and as I said, we do see cylinders in many places, so it's worth knowing how to find the volume of a cylinder. Alright, so let's label this up. I've shaded the base blue and I've labelled the perpendicular height h, and we are noting this, that like prisms, because the slices are congruent, and by slices I mean horizontal cross-sections in this diagram, the area of any slice multiplied by the height gives the volume. So the textbook is reminding us that the area of a circle is pi r squared, so the volume of a cylinder is pi r squared times h, and I've labelled the radius r, and I'm just going to draw in a little right angle symbol to remind you that height has to be perpendicular to the radius, which lies in the plane of the base. Now, remember that when you're solving problems in geometry, it's a very good idea to begin with a diagram. If one isn't given to you, then I recommend that you draw one. We should also remember that because the cross-sections are congruent with the area of the base in this shape, just as they were with prisms, then the general formula is volume equals area of the base times the height. So let's look at a very straightforward example. We're asked to find the volume of a cylinder of radius 7 centimeters and height 3 centimeters. Now let me just label the diagram here. Area of the base is pi r squared, it's a circle, and h is the perpendicular height. Next step, start with the formula, v equals pi r squared times h. Now we substitute the values, 7 squared times 3, and we get 147 pi centimeters cubed. That's the answer to A. For B, we're asked to approximate the volume using pi equals 22 over 7, so now I can substitute that, and 147 divided by 7 is 21, and you can figure out that the product of 21 and 22 is 462. Don't forget the units. In this case, it's centimeters cubed. That's about it. Go ahead and try exercise 15E. I think there's only 3 questions. You can try them all at your own leisure.